Before I start, I'm just so impressed by this wonderful conference. In fact, I've been taking notes studiously for the last 2 days because there is so much valuable information that I can actually be taking back home for myself. So I'd really like to thank the LDD and the Asia Development Bank giving me the opportunity to come, because I've been as much of a student as I will be presenting today. If at any time I am speaking too quickly or you don't understand my Australian accent, you can just put up your hand and I will repeat it again. My talk is very simple. I'm not a technical person, more like a concept person, and I work with the average person off the street. One of the main things I do is I teach composting to anyone that wants to learn how to do composting, which we'll talk a little bit more about today, and the farmers might find this a bit easier to understand. Yeah. One thing I would like to say, would you mind bringing the whiteboard down? The whiteboard? Thank you. One thing I'd really like to say, and I like, when I come before farmers, I would really like to thank farmers of the world. It's a very, very important role. Farmers feed the nation's people, and yet in our country we have less than 3% of the population who are farmers who grow the food for the nation. And in our country, many farmers are very depressed because farming is so hard that they're actually taking their own life. So at any opportunity, I think we should give a big round of applause to all the farmers that are here for the great contribution they have to their own country and society. So here's to the farmers. They don't get it. I can already tell you're not understanding my English. Okay, no problem. So we're in a very crucial time, aren't we? We sit at a very big crossroad in our human society and our human culture and civilization. So I think it's a really important thing that we acknowledge a few things that our life depends on. What are those really primary things? What are technologies in nature that we can actually learn from that will actually help ourselves develop climate-friendly communities, climate-friendly agriculture? A lot of these we just take for granted, and here's a few. Air. How many of us take air for granted? What an amazing thing it is. 3 minutes. 3 minutes without air and we die. And yet this is a free service provided by the natural environment for us all the time. And as people working in agriculture, we actually have a role to protect the environment in such a way that people tomorrow can enjoy oxygen. So amazing technology from nature, okay? Here's carbon dioxide. The tree takes it in and it separates carbon from oxygen. I mean, how difficult is it to separate carbon from oxygen? Think about that. Now, the other thing that's interesting about this system in nature is that the oxygen is a waste product from the tree, okay? So here's oxygen as a waste product, but it's a resource for us. And the same thing, carbon dioxide is a waste product from us, but it's a resource for the tree. So we're interconnected intimately by this simple process in nature. What about the water cycle? How important is water for agriculture? Don't we want to preserve the water cycle? Don't we want to preserve the purity of the water? So we need to start to think more deeply about that. How about this system? Powered by the sun, water is lifted by evaporation. The salt, where does the salt stay? The salt stays in the ocean to make purified water. How much energy does it take to do this? An incredible amount of energy. How much do we pay for it? Nothing. But we do have a responsibility to protect this natural cycle of nature. In Australia, for instance, we're having to start to make desalination plants at a great cost to the community. Incredible. So let's think about that one. And my favourite, composting, the unstoppable force in nature, as old as the dinosaur, literally millions of years, through the action of weather, through the reaction of volcanoes, the interaction of clay, and all this micro life under the soil and the macro life on top of the soil, that's allowed us to have the environment that we have today. So we've got this history. We can't recreate what nature has taken billions of years to make, but we need to be able to preserve and conserve it for the future. So here's just a simple part of the compost cycle. We always talk about the carbon cycle, but it's not only the carbon cycle, it's the nitrogen cycle, it's the water cycle. All those elements come together to make up the composting cycle. So if we have a look at, say, a rainforest system, we don't need to put agricultural fertiliser into a rainforest system, do we? Or in those great grasslands that have existed for eons, no fertiliser was ever necessary. So what's happening there? What's different? What can we learn from that to apply to agriculture? And for me, the secret is, and we've learnt so much more about this in the last 25 years, and we've heard from great speakers today about soil life and also plant diversity. In the rainforest, there's a huge diversity of plants. And under the soil, that allows a huge diversity of micro-life to be in there, and that interaction creates a healthy system. The grassland plains, more than 50 species of grass. But when you look from the outside, it looks like there's one or two, but there's the very low-growing ones, there's the tall ones, there's the intermediate ones, and underneath that, each one of those grass has a different relationship to microorganisms, and together they build the soil health. What do we need to do to it? Well, just add a bit of water, let the organic matter rot back down, and the system keeps going. So it's been managing itself for literally millions of years. So where does that put us now? Let's have a bit of a closer look. What we've really learnt in the last 25 years is this area underneath the ground is perhaps the most important thing to consider when we talk about agriculture. Before, we always used to think, oh, what's above the soil, you know, just focusing on that. Now, in this area around the root zone is an incredible amount of life and interactions happening. In fact, it's the most important area. And a thing that we really have only just started, I think, to grasp. Sorry, it's a pity. I've had my PowerPoint recopied to a lower form. Anyway, what it says on the left-hand side here, it hasn't come up. It says, I'll draw it on the board, it's easier. So in a healthy system, plants, through their roots, can't get any nutrients out of the soil unless there's microbes. So they're like the interface between the roots and the plants. So if the microbes aren't there, what's going to happen? The plant can't grow, the plant can't live. So we'd really start to need to think about, well, what is that microbe system actually doing? How does that work? And we're very lucky, and unfortunately it doesn't say it there, but a microbiologist called Dr. Elaine Ingham is responsible for much of the amazing information, scientific information that we have now on what she's called the soil food web. So basically, there are organisms in the soil, and this might make it easier for some of the farmers, I hope, from the very, very minute to the very large. All these organisms work together, but why it's called the soil food web is, let's just say, the most basic are fungi and bacteria. They're the smallest they're the smallest organisms, and they do the initial decay of organic matter in the soil, okay? Then there's another range of organisms that actually eat. One step, eat the fungi and the bacteria, okay? So they're the resource, they're the life for the next life up. Unfortunately, you can't see it there, but it says the fungi and bacteria are often eaten by the protozoa or the springtails or the nematodes or the mites. But at every stage, so basically it's a very simple system. A creature is a food source for another creature, who's a food source for another creature. At every stage they go to the toilet, okay? So they eat food and they go to the toilet. We do the same, don't we? Okay? So every time they go to the toilet, they actually put nutrients back in the soil, okay? And then they die off. They also lock those nutrients up in their body, and later, that's how mineralisation actually happens. That's how those nutrients actually become available through the body of the organism. So to get the idea, very simple system. So all the time, organic matter is being digested, and without this organic matter in the soil, as people have been talking about, if we don't have the range of about 5%, we don't actually have a home for these microorganisms to live. Therefore, all the nutrients that we want to get out of the soil can't happen because there isn't this life cycle happening. Okay, very simple, but very important. Okay, so this just gives you a better look at it. And as we've started to be talking about health as well, so there's what the soil food web have found is, particularly in the fungi sort of area, there's a whole lot of fungi that when they get larger, over 3 micron hyphae, they actually are disease-suppressing fungi. Okay, so if we can encourage those disease-suppressing fungi to naturally be part of our system, then we don't have to worry about pests in that regard. Okay. Other things that people haven't known for ages, then there's the nematodes. People think nematodes are really bad, but there's a whole range of nematodes, larger nematodes that eat smaller nematodes that do the same thing. So all that root being eaten by nematodes, if they've got the right succession of nematodes, then that doesn't happen either. Okay, I'll just give you one more example. This is an example of all the different types of bacteria in a healthy system. If we had this in our soil, we wouldn't need to put any pesticides on, because you'd have the range and diversity of life that would actually control the health in the soil. For instance, these ones down here, this is the Actomycetes series. Fantastic. They're a naturally occurring antibiotic, okay? So what does that do? That stops. That's like sterilising the soil. It stops those creatures from actually bringing disease and pests to there. And then we've got all these other processes. So although we're having nitrogen deposited in the soil, if we don't have nitrogen fixing bacteria in the soil, where does it stay? It stays not being available to the roots to actually take off. So we need those. We need that range of organisms as well. Oh, there's a whole lot over here, but another one that I really like is the photosynthetic bacteria. They're the ones that do the amazing job to remove all those smelly type things to our nose. They're the ones that actually stop the greenhouse gases. Okay? So if we don't have this range of photosynthetic bacteria, amazing bacteria, what they do is they photosynthesize in low light conditions, and they love things like sulfur. So all the things that are detrimental to the greenhouse, detrimental to actually soil health, they eat up underneath the soil without very much light, and they create oxygen. Oxygen under the soil creates a better environment for the roots to live. Okay, so for my way of thinking, there are two big things that are missing these days, and that's the loss of, that should say loss of soil microbe habitat. Now, if you don't have the environment for the microbes to live in the first place, how are you ever going to have them proliferate and do that job of converting all those nutrients to be plant available? And then, of course, that second one should actually say the loss of soil nutrients. So, I mean, pretty much this has been taken care of by all the other speakers. But I suppose the most important thing to me is just the loss of habitat for soil microbes. I think anything else. And the other great thing is that that really concerns me, and this is the area where I work. Literally, farming is mining nutrients out of the ground. Do you not agree? And that every time we grow a crop, we actually export those nutrients somewhere else. Yes? Yes. So it makes common sense that we've taken so much out that we've got to put so much back. You know, makes common sense, okay? But there's an incredible amount of wasted resource that, say, goes to the city and never goes anywhere. It gets buried in a landfill and it's just a lost resource. So to build systems like nature has, it would be normal that we have infrastructure to recycle all that organic waste. So what are some of the potential waste resources to recycle into compost and to create this food for soil microbes, or to create that habitat for microbes to live in the soil? Look, these are just a couple of examples, and I'm sure you can come up with far more in your own area. All the fruit and vegetable waste that goes to the city that just, either doesn't get collected or just goes to landfill, gets buried in landfill, creates methane, and we know what methane does. What a wasted resource. There's all the green waste. As I drive around Bangkok, my gosh, I could go compost crazy here. There's so much resource that we could be converting into beautiful habitat and food for the soil, just sitting around waiting for someone to say, yep, let's go. Also, there's all the waste that comes from forestry as well. Of course, and we eat food and we go to the toilet too, all those biosolids, What an amazing source that could be reintroduced back into compost systems and back onto soil. So you can apply that for your own situation. So let's just talk about some of the benefits of composting quickly and its potential to contribute to climate-friendly communities. As a soil conditioner, really high quality compost can actually change the conditions of clay soil, silty soil and sandy soil. All about the interaction of both the humus that you get from it and the microbiology. If you've ever seen a good compost added to clay soil, after a year you start to see the true effect of it. If you took a cut down there, you would see, especially if you've got worms on the surface, you would see black filaments coming down through the clay profile, and that's the action of microorganisms being allowed other larger organisms, say like worms, to actually start to incorporate that humus into the soil. That, of course, then provides pathways for air and, of course, the roots to go down to. They're very, very simple. As a fertiliser, all those nutrients are plant available, which means, but different, plant available in a different way. Of course, we know with chemical fertilisers, the plant just has to take them up. This type of plant nutrient availability is there's a communication between the roots of the plants through the microbes and the nutrients in the soil. So they communicate with each other, and the root says, I need this elements from the soil, and then it provides them in the right amount, the right proportion. Very, very different sort of scenario. And of course, building pest and disease immunity I've briefly spoken about. Look, it has the potential to recycle thousands of tonnes of organic waste in a very simple and easy managed system. Can be done anywhere. And of course, the opportunity to save money. So you can think about that. On a more global scale, of course, sustainability is broken up into waste, water, energy and biodiversity. Just very briefly, we talked about the waste situation. Water, I don't know whether you know, but if you build good humus in your soil and you have good soil microbe activity, these dead microbes, they actually bind to the humus and they stop nutrients from being leached away. So one of the big things that we have is nutrients just being leached into waterways, and of course those nutrients create too much nutrient for that waterway, and of course they despoil the water. Energy, anyone seen a hot compost? Hot composting systems? Who's doing composting? Yep. Okay, so in a hot composting system, it gets to about 70 degrees Celsius. So in a well-made hot compost system gets about 70 degrees Celsius. This sanitizes or pasteurises, kills weed seeds, kills pests, kills diseases. So it has a great ability to actually, whatever your ingredients are, it will actually provide the opportunity to knock out pests and diseases. Okay, biodiversity, how can we say? That compost in its contribution to biodiversity is just not appreciated enough. The amount, in fact, we could do a simple example, I think. I'll talk about it in a minute in the principles of composting. So hopefully, now I'm just going to talk really simply about how to make a good compost, okay? And of course, I call it black gold, because this black gold is more valuable than gold to agricultural soils, okay? So the first thing we've spoken about is this is a dynamic living system. You've got to treat it like a living system, okay? You can't treat it like, okay, we're just going to put these ingredients together and hey presto. We have to consider, okay, what's this living system going to need to live to not only survive but flourish? Now, just to give you an example of how many microorganisms and its contribution to this, what do you think in one handful of a good made compost, how many microorganisms there would be? And I want someone to give me some feedback here. How about 3 guesses? Okay, anyone, just yell out. 3 guesses. Go on. My friends from China, come on, any number you want. One handful of microorganisms. You probably know, you're a microbiologist probably. No, just tell me. Just call out a number. It doesn't have to be so complicated. It's just fun. It's fun, okay? Easy does it. So, 2 million. Thank you, sir. 2 million, 2 million, 2 million. Anyone want to increase on 2 million? 2 million microorganisms in one handful of compost. Do we have more than 2 million? 10 to the power. Maybe not that many, but pretty good. Okay, so we've got an increase. We've got 10 million. Okay, we've got 2 million, 10 million. Any increases on 10 million? 10 million going once, 10 million going twice. 10 million going 3 times? 10 to the power 100. Look, it's very optimistic. But let's just so we're really clear. Look, in one handful of compost, raw-made compost, there are 10 to 20 billion microorganisms. One handful. Convert that to 1 tonne, and then you can have your 10 to the 10. Absolutely. So its contribution to biodiversity is just absolutely amazing. Okay, so let's learn some of the secrets that actually make a really good compost. Okay, so we talked about a living system. So what do you need to live? Okay, what's the first thing? I know the Chinese can't go without. Chinese can't go without food, can they? They have to eat. And they're always thinking about when the next meal is coming. I know, I've got good friends who are Chinese. So the food that we put into the compost really makes a difference. If we have, if we have a large variety of food, it makes a difference to the end product. For instance, if I said to you after today when you went home, for the rest of your life, you're only going to eat rice, nothing else. How do you think that's going to affect your living system? Are you going to maintain good health? No, of course not. So that's the same with the compost. If we just put 1 or 2 ingredients in, it's not going to make a high quality compost. We can't get the diversity of microorganisms we want in there just with a few ingredients. But if we take a variety of ingredients and put them together, we're going to get a healthier compost. There's going to be less maintenance, and the quality at the end is just going to be far better. So that's the first thing. Food. Living system, food. Think about the food you're going to put into it, just like you and me. Now the next thing is aeration. The microbes that we want to encourage in this system breathe air, just like you and me. So we need to think about how do we incorporate air into the structure of the compost. All right? Now, one of the things that stops it doing, if you've ever smelled not such a good compost, it goes very smelly. They're from non-air breathing microorganisms. That's what we're trying to stop. So aeration. The last one is water. All life needs water. Microbes need water to live, to reproduce, and to do their job of decaying that organic material. Very simple. 4 points you need to remember to make good compost, okay? It's dynamically alive, okay? We have to treat it like a living system. Think about the food that you're going to put in, and we're going to have a look at the food in a bit more depth. Think about air. You can't breathe, 3 minutes, you're gone. Like the microbes in there, we need to have air and water. As the process goes on, if water disappears, the process of composting stops and we don't get that beautiful decay and final end product. So when we talk about the food or the compost ingredients, we can divide it into 2 very simple categories. And you might not be able to see it up on the board, so I'll just draw up on there, so I'll just write it over here. And these are materials that are green, materials that have moisture or some sort of level of water still in them, and they're still living or they're alive, okay? One very broad category, and the experts would call it nitrogen. So when I talk to people off the street, they can't remember nitrogen, but they can remember green, wet or alive. Oh, okay. I can look for things that are green, wet and alive. Can do that. The next one is things that are brown in colour, they're dry in appearance, and they look pretty dead. Us technical people here, we would know that as carbon. But it's not necessary for people to know it as carbon, they just need to know they're looking for things that are brown, dry and dead. Okay, so let's start to just classify materials, start to separate them into those 2 broad categories. Okay, what have I got here? Okay. I wanted to bring some more materials, but here's a good one to start off with. Cow manure. say cow manure fresh from the paddock, okay? Now, who would like to guess? Is that green, wet and alive or brown, dry and dead? Not a hard question. Okay, cow manure straight from a cow, that cow gut, 4 chambers, beautiful fermentation process happening in there, all that microbiology from the gut out there. What do you think? Is that, well, it's pretty dark green. It's definitely got lots of moisture in it, and it is absolutely teeming with life. So it would be a green, wet and alive. So manures, fresh manures, green, wet and alive. I'm just giving you a couple of examples. What about fruit and vegetable waste? Straight from the kitchen. What do you think? Are they still living? Yep. Have they got a good level of moisture in them? Yep. Some of them are green, others are not, but certainly they tick the wet and alive things, so kitchen waste, or vegetable waste. Green, wet and alive. I'll just do one more. Fruit waste. Now, then I'm going to throw in a tricky one in a minute, just to make you think about it. Fruit waste, the same thing. Still living, isn't it? Still high percentage of moisture in it. And so fruit waste would be green, wet and alive, okay? Right. Okie dokie. All right, let's, and there's a whole lot of other ones. Here we go, fresh grass. I've just picked out some things. Couldn't help myself, walking around at lunchtime. Just wanted to get a few things. Fresh grass, green, wet and alive, okay? Beautiful source, got nitrogen in it. Weeds. I don't know why people are so negative about weeds, but weeds, fantastic in a compost. Weeds, this diversity of plants brings different nutrients up, different associations with biology. That's that diversity that we're talking about, that variety of food. So we could put, the only qualification with weeds is weeds without seeds. And fresh grass. All sorts of grasses, okay. Now let's move on to things that are brown, dry and dead. Okay, so I've got some rice straw here, okay? Rice straw looks pretty brown, doesn't it? Looks pretty dry, pretty dead. So rice straw. Great source of carbon, a great element in the compost. Its sheer physical structure actually helps air remain in the compost. So it's a great ingredient to have. Okay. What else have we got there? Oh, soybean meal. Okay, that's for after. Okay. I picked up a few things. Dry leaves. Brown, dry and dead. Go into the compost side of here, so dry leaves. And I'll just do one more just because I found this outside. All the coconut husk, coir type material, beautiful. Now, that's just to give you an example, and look, you can look this up anywhere. Plenty of other things, all paper products, sawdust, manures when they really dry out a lot, they become brown, dry and dead. So when they're alive, they're a green, wet and alive. And as they dry out, they become a brown, dry and dead. So what about something like the maize stalk or the corn stalk after the corn's been taken away? Anyone want to say where that would go? No? Okay, so when it's first harvested, it's very green and alive, isn't it? Okay, so corn stalk, when it's fresh, would go here. But as it dries out, where does it go? It goes here. So you can very easily change a material from being green, wet and alive to brown, or quite a few of them, to brown, dry and dead, just simply by time. And this may be convenient for you because you may need to have more carbon where you are, or you may need to have more nitrogen where you are, and so you can develop your own recipe. because there is, I'll get to there in a minute. Now, I've got another one, 10% by volume column. Now, what we've found is that anything that's highly acidic, so that would be all your citrus, so lemons, limes, grapefruit, pineapple, these things, where they're highly acidic, if you put about more than 10% in your compost, what it does is it steals nitrogen, okay? Too hard to break down, so only 10%. Anything that's really alkaline, so that would be ash, or liming agents like lime itself or dolomite or gypsum, only at 10% into the compost to get a good end result. And anything that's really oily, for instance, that could be chili, capsicum, those types of plants, or herbs that we get essential oils from, so lavender would be an example. So those types of things, only 10% by volume. Depending on where you go, if you're going to be doing this at home, you would avoid some things. So meat products, or even on a small scale, fish products, meat products, a lot of dairy you wouldn't put into the compost, but maybe on a larger scale be okay. Just we need to be a little bit careful with the pathogens that could be present on those materials if they've been sitting around for a while. Okie dokie. So, carbon-nitrogen ratio to make a successful aerobic compost. Now, this is the key. So this is the time you need to wake up, okay? If you don't remember anything else from this talk, remember this, okay? So this is like the secret to the universe. If you're able to achieve a good carbon-nitrogen ratio, what you get as the end result is you get the maximum nitrogen available, and also you get the greatest diversity of microorganisms giving up all the nutrients that you put in the ingredients. Okay? So, would anyone like to guess what the perfect carbon-nitrogen ratio is? Come on, you've got to give me some feedback now. I'm not used to people just sitting there with, just looking at me. So, let's have, say, 3 guesses of what the perfect carbon-nitrogen ratio is. Come on, we've got so much knowledge in this room, so many talented people, I'm sure we could at least get 3 guesses. 20? 20 to what? 20 to 1. I'm going to ask by volume. Yeah. So, a bit more difficult. I'll make it easier, because this is by volume. So we're going to take so much. Nitrogen material, so much green, wet, and alive material. We're going to take so much brown, dry, and dead material, and we're going to mix them together. How many handfuls of nitrogen, green, wet, and alive material are we going to take? And how many handfuls of carbon material, brown, dry, and dead material are we going to take? Come on, there's lots of people in this room that make compost. I'm sure you can tell me. It's not a test, by the way. 12 to 1? Okay, so 12 parts nitrogen, is that right? To 1 part carbon. That's a good guess. 1 to 12? Okay. Yep. Anyone else? I'll help you. How about we put 50% carbon and 50% nitrogen in? And this is what I normally get in a workshop. Most people say, let's put 70% nitrogen in, green, wet and alive, and 30% carbon material in. Anyone agree with any of those? No? Show of hands? No? Okay. Well, normally what happens now is, because everyone's waiting to hear the answer, I make them tap their desks like a drum roll, because it's so important that you remember this. So, do you reckon you can give me a drum roll? I can see I've got a few fans here. So this is the really important thing. By volume, we take 1 part nitrogen to 3 or 4 parts carbon. It's a very important ratio to remember. And what this will do, this will give you a high nitrogen or higher nitrogen fertiliser. So 1 part nitrogen to 3 or 4 parts carbon. Okay, so why is this so important? Okay, the microbes that are doing the decomposition, what they're doing is they're going along eating the brown, dry and dead material. And to get a nice rounding for their digestion, they need to then grab 1 part of nitrogen. Okay, so it's like they're going along, they're eating 4 handfuls of carbon, and then they're going to grab a handful of nitrogen and throw that into the mix, and then they're going to gobble that all up. Okay, so this is why this ratio works. So more than any other elements, that's what the microbes need. So as you know, carbon is the source of their life, and the nitrogen helps them build protein. Okay, so that's how they reproduce and metabolise. That's why that ratio is so important. Really easy way that we teach people is the rule of thumb, okay? And the rule of thumb says 1 part nitrogen to 3 or 4 parts carbon. Very simple way, not difficult, if you can remember that. And we actually use this same rule of thumb to help people build compost on a very simple scale in the backyard. So can everyone read that? This is called the layering method, or the lasagna method for those that like Italian food. So what we're going to do is we're going to take carbon, brown, dry, dead material, about this thickness, literally 3 or 4 fingers thick. Yep. And we're going to put that on the ground or in an enclosure. And then on top of that, well, actually we're going to water it first. And then we're going to add 1 layer of nitrogen type material. That could be manure, could be fruit and vegetable waste, could be green weeds or fresh grass, could be fresh corn stalks chopped up. So very simple. And then we're going to put another layer on top of carbon material. Very simple. And we're going to water the carbon material, for without water there is no life. And what would be really good is if we had different types of carbon material to throw in. So if we had some dry corn stalks and some dry leaves, dry grass, and we mix that all up together to make our layers of carbon. Beautiful. And then we keep building that up and up and up and up. And then on the top, we always cap it off with a layer of carbon material. And the simple matter is that if we put carbon on top, then insects don't find the compost heap. And then it's nice to put a little cover over the top, tuck it in, make it feel nice and warm and comfortable. Okay, and as it says here, water every layer, very, very important. Okay, so the doctor before lunch was talking about testing for moisture. So what is the correct moisture level in a compost? Would you believe it's about 56 to 60% water? That's a lot of water. Okay, now you can't put this water into the compost after you make the compost. No way. So some things you can do is you can soak the materials first. Okay, get the water in early. Or you can have ways, what I do at home is I have a wheelbarrow or a container. I can literally get my rice straw or wheat straw and I soak it in the water, get it nice and wet, and then I pick it up and then I layer into the compost. Okay? So how do you test? Does anyone know about the squeeze test for moisture? Yeah. So very simple. All you have to do, and this is a scientific method, would you believe? The squeeze test. So after you make your compost, after say a week or so, if you make in one batch, you can literally put your hand right in the middle of the compost, pull it out and lift it up, and you should be able to hear the moisture when you squeeze it. You should be able to feel the moisture in your hand, but when you squeeze it tight, the moisture shouldn't come out. That is the perfect amount of moisture. Now, if you find your compost is too wet, then you need to turn your compost, let it dry out a bit, and heap it up again. Often when you turn it, you find there are drier bits and you can mix it together with your drier bits. And if it's too dry, then you need to be able to water it as well. Okay, so turning is a really important factor, especially on small-scale composting. It speeds up the composting process. So if you keep turning the material, you can have finished compost in about 8 to 10 weeks. and you can have a really good microbial activity during that time, and you'll get a good end result. Now, this is probably the other thing that's really important to look at, and this is, so the key for creating heat in the compost heap is there's a critical mass. So you actually need a volume more than 1 cubic metre of material to make sufficient heat in the compost to pasteurise or sanitise, to kill off weeds, to kill off diseases, and to actually get the greatest decomposition in the fastest period of time. So if you have less than that, it's just not going to do the job that you want. It will be a cold composting system, and that's quite different, and it can work really well, but that really works on, does work on microbiology, but it works a lot more on the macro creatures that are there, so slaters, earwigs, worms, those types of creatures. Okay, so this is just showing you a chart of how the temperature changes during the composting process. Certainly there are different ranges of microorganisms. So there's a lower temperature range of microorganisms, and when the temperature gets to about 40 degrees Celsius, then a whole other range of microorganisms come in, and then there's a huge rapid decomposition, and you'll see your compost heap collapses. Okay? That's because an amazing amount of energy is being released, and an amazing amount of materials are being absorbed. In fact, the nitrogen materials, they disappear really quickly into the bodies of the organisms. So during this period of time, maybe after about 2 weeks, depending on what you're doing, what style of composting, aerobic, you really need to turn the heap. Okay, because turning the heap's going to add more air back into the system again. It'll fire up, and if you need to water, you can add water, and if you've got really wet parts, you can actually combine it together with drier parts. Now, as the temperature drops off, this is where it gets really tricky. At that point in time, say when it drops below 40 degrees, it's composted, but it's not mature. And the real point to receive here is, if you put immature compost out, you can kill plants quite easily. And the reason is because the compost still needs carbon, it still needs nitrogen, it still needs water, and it still needs air. And where's that going to get it from? It's going to take it from the soil or the plants. So maturing compost is a really important step to take. How do you know that? And it's where the real magic happens. So if you turned your compost again and it didn't heat up, it stayed at about ambient temperature, then you know the composting process has finished. Also, before that time, depending on where you are, you'd see other larger organisms come in. So worms are a really good indicator that the composting process is getting near the end of the process. And it's where the real magic of compost happens. If you allow the maturing process to happen in its own time in the proper way, that's when those nutrients, those mineralised nutrients locked up in the body of the microbes, actually get released into the compost. So that's why it's really important. Before that time, all those minerals are actually still locked up in the bodies of those microorganisms. And so that's why people say often, there's only this much available of nitrogen in that compost, and that's because it hasn't been matured properly. Okay, so it's a really important factor to take into consideration. Now, I better have a time check. How much time have I got left? 10 minutes? Okay. I'll be very brief. Some of the other work I do with local governments is looking at low technology ways to actually convert organic waste into a usable compost. So one thing that we've been trialling is, you can see these are actually just pipes with holes drilled in them, and they're actually going to provide the air into the compost heap. So we don't have to turn it, okay? So we're trying to think about simple ways that farmers can actually do this. and also local councils can do this. So basically, in this green box that you see, I've got the pointer. The green box on the top left, basically that's got a little pump in it, a little air pump, and on the side of it, it's got a thermostat. So every time the compost gets to 64 degrees Celsius, the fan turns on, it gently blows air in, and then the temperature drops down, and as soon as it gets to 60 degrees, it turns off again. And then if the temperature comes up again, 64 degrees, bling, on it comes again and down. And that way we can actually make it quite a simple process. The only downside is that you have to be certain about the amount of air that you blow in, otherwise you dry out the compost, and wherever there's not water in the compost, the process stops. So a good simple technology, and in this technology we can actually even cover the heaps, and there's a special type of material that actually breathes, so we don't get influenced by the outside like rainfall as well. This is a large process I did with a local council. This was using the fermentation style of composting using effective microbes, and we were, let's see, we're doing about 12 tonnes a week, only a small council, and it was showing them that they could very easily manage this. The effective microbes, as you know, has those photosynthetic bacteria, so they eat all the smelly greenhouse gases, and the fascinating thing about it is that they do release both oxygen and water back into the process, and it's a very simple process, or basically, and we've come a long way since then and been working with a group of like-minded composters in Australia, so we're actually not buying the EM anymore. We're harvesting indigenous microorganisms from the local area and then making our own liquid brew through a bokashi type system, and then making a liquid from the bokashi. And so farmers can very easily, you know, be the recipient of all this beautiful material and be making the compost on site. We've just got a couple of farming sites now. Okay, and this is just another farming site, and just showing you some different processes that we're using. Turning, what we're doing is we're just using a very simple device that's actually like a rotary hoe. Do you know what a rotary hoe is? I've seen rotary, you've got rotary hose here. And literally it's doing the blending and the turning, keeping the air back in the system. So quite a low cost type input, and this is actually using waste from a paper mill, as well as animal manures and shredded green waste from the city. Okay. This is just showing you some of the different types of fungi that are up here in the process using the indigenous microbes from the local area and our microbe brew, and that's just me when I was younger, spraying it out on the side of the compost heap. Okay, great.